Hi guys, Mrs. Gartner here. Today I want to take you through a day 2 for lesson 5-6 of graphing those inequalities on a coordinate plane. In order to do today, if you could T and title your notebook with this setup for me, please. And then you need, besides your notebook, that yellow worksheet. For our examples today, you need your pencil, and then colored pencils or markers, whatever you choose to use to do our shading today. All right, so first thing, just a reminder, exactly what we talked about yesterday. When we graph inequalities into variables, it's really important that you've got a very specific boundary line. So, just a reminder that if it's let's see here. If it is a less than or greater than symbol, you need to make sure you use a dashed line for your coordinate plane, line that goes across your coordinate plane. Reminder that you do not want to include the points on that boundary line. So that is not part of your solution. The solution will be everything above or everything below. All right, and then also just a quick reminder, if it's a less than or equal to or greater than or equal to, we need to use a solid line. That means that those points on the boundary line, they are part of the solution, as well as everything else we shade above or below that line. So just a quick reminder, don't know if you need to write that down again, but reminder that when we do our graphing, you've got either that dashed line or that solid line. All right, let's do some examples. First one on your yellow sheet, if you could please, on your first blank, copy down that first equation. We've got 2y minus 4x is greater than 6. You can see what's different about this equation from yesterday is this equation is not in slope-intercept form. Had to ramp it up a little bit on you guys. So my goal for you today is to do a little bit of algebra. Let's rewrite this inequality in slope-intercept form, get the y by itself, and then we'll be good to go to graph. All right, so goal, if we want to get y by itself, I'm going to add the 4x to the other side. I'm going to bring down 2y is greater than 4x plus 6. Then to get y by itself, I'm going to divide everything by 2. The inequality I would love to see on your first example today is y is greater than 2x plus 3. Circle square that inequality. That's what we need to graph. You hopefully have a little bit more space so you can identify which of those numbers is your m and which of those numbers is your b. Hopefully you see that that slope is 2. What's next, that x variable there, and then the y-intercept is 3. All right, so now go to your coordinate plane. Let's graph this line. We need to graph the y-intercept at 3 first, so we need to do a dot at 3. And then remember, slope as a fraction should be 2 over 1. So up 2 over 1, up 2 over 1. Keep that going in both directions. Remember, we can't have any lazy lines here. It's got to go all the way across your graph. All right, and then last reminder is go and look at that inequality symbol. Since it's a greater than symbol, we need to use a dashed line. I would write that down in your notes, just a reminder. That means we need a dashed line going through those points. So connect those points, leave some space between so it's very obvious that we've got a dashed line going across that coordinate plane. All right, so this means the solution does not lie on the line. It either lies to the left of the line or to the right of the line. So we are going to test a coordinate point. The easiest one to test is 0, 0 at the origin. This is the one we're checking out right here. Is that part of my solution? All right, what I would do is I would just substitute into your brand new slope-intercept form equation.
Khadija, Saeed to the office, please. Khadija, Saeed to the office.
Excellent. That was an announcement. So we're going to plug in x and y. So here we go. We've got 0 is greater than 2 times 0 plus 3. All right, and check it out. 2 times 0 just becomes 0. So what's left over is 0 is greater than 3, and you need to ask yourself, is that a true statement? And hopefully you know, no, 0 is not greater than 3. So that is a frowny face, meaning the origin is a frowny face, so that is not part of the solution. So we need to go then, I'm just getting my highlighter here, and shade all the solutions that are to the left of that dashed line. So take your highlighter, take your marker. I want you to shade in everything to the left. Remember, in order to get credit today, you need to show me your algebra to rewrite things into slope-intercept form. You need to show me how you test a point, where to shade, and then you need to shade completely either everything to the left of that boundary line or everything to the right. Awesome. All right, one done. Let's do the next one. Here's your next one. On your yellow piece of paper, could you please copy down y minus 3x is less than 2. Y minus 3x is less than 2. So you can see it right up here. And hopefully red lights flashing here. This is definitely not in slope-intercept form. But all I got to do is get y by itself. So to get y by itself, oh yeah, we just got to add 3x. So drop that down. We've got y is less than 3x plus 2. Done. Some of them are really nice. So you just grab what you got there. We got y by itself. Give me 2 blanks, m and b. And hopefully you see the slope of this line is 3. The y-intercept is that 2. So now let's go to your coordinate plane. Go up 2. We need to graph that y-intercept at 2. And then from there, as a fraction, my slope would be up 3 over 1. Up 3 over 1. Or down 3 and left 1. 1, 2, 3. 1, 2, 3. All the way across your coordinate plane. Before you connect those points, check out your inequality symbol. It's a less than symbol, meaning we need a dashed line. So I'm going to connect these points with a dashed line. Make that obvious. All right. And then last thing we got to do, we got to figure out where's the rest of this solution. Is it to the left or is it to the right? So we're going to test this xy coordinate point, 0, 0. I would plug that in for x and I would plug that in for y. So is 0 less than 3 times 0 plus 2? 3 times 0 eliminates. And I've got the statement 0 is less than 2. Which is true. 2 is definitely bigger than 0. So that means the origin, this point right here, is a solution. That means all my solutions are to the right of my boundary line. So just grabbing my highlighter again, I am going to shade everything to the right. I would like you to do the same in your notes, please. Making sure we got no lazy graphs here. We've got lines that go all the way across, and you've shaded everything across to the left of that boundary line. This means my solution lies everything to the left. It does not include the boundary line, and it does not include anything to the right. All right, let's keep going. 2 done. Next one. Find another blank coordinate plane, please. Next graph I want you to write down. X plus 2y is less than or equal to 4. Once again, that's read x plus 2y is less than or equal to 4. All right, so check it out. If I want to get y by itself, I need to get rid of that x variable, move it to the other side. I can get rid of a positive x by subtracting x. Drop down 2y is less than or equal to negative x plus 4. Then to get y by itself, I'm going to divide by 2. Be careful what's hiding in front of that x. You've got that hidden -1 coefficient. So we're going to pull the fraction. I want you to pull this away from the x variable. We've got y is less than or equal to -1/2 x plus 2. Awesome. What's your m? What's your b? Why don't you identify that real quick? Hopefully you see your m is -1/2 and your b is 2. Now we have enough info, we can go to our coordinate plane. If I go up 2 on my y-axis, I can mark my y-intercept. Careful, we got a negative slope this time, so we're going to go down 1 and then right 2. Down 1, right 2. Not as steep of a slope here. If you reverse it, up 1 and left 2 is going to keep that line going in the opposite direction. Before you connect those points, check out your inequality. It is a less than or equal to, meaning we need a solid line this time, ladies and gentlemen. So we need to connect those points with a solid line all the way across your coordinate plane. That means that this line is part of our solution, so we will include that as part of our answer. Now we just got to figure out, is everything else above that line or below that line? So let's go check. I'm going to plug 0 in for x, 0 in for y, because I do notice that my origin is not on my boundary line, so I am good to go. If I plug 0 in for x and 0 in for y, show me this check work if you want credit. 0 is less than or equal to -1/2 times 0 plus 2. Lucky us, -1/2 times 0, gone. So 0 is less than or equal to 2, which, since 0 is less than or equal to 2, this is a true statement, meaning the origin is a solution. So all of our solutions lie, you guessed it, below that coordinate plane. Let's go blue. So let's start shading. All of this becomes part of my answer. Shade it in. Awesome. So the solution lies on the line. The solution lies everything below the line. We can pull any of these nice coordinate points. If I get back to my pen here. Any of these nice coordinate points along the x-axis. Like this would be a solution. This would be a solution. Over 2, stay at 0 would be a solution. Same thing, anything in this blue. All is fair game to be part of our solution for this coordinate plane. So kind of cool. All right, as always, I save the last 2 are my best. So last 2 examples. Careful, these ones get tricky, so definitely get these down. All right, find me a blank graph line. You need to copy down 2x plus 3 is less than or equal to 7. 2x plus 3 is less than or equal to 7. Get in your tracks. What is interesting about this inequality is I've always asked you to get y by itself. Get this in slope-intercept form. There's no y. So we get a different type of graph here. Your only variable is x, so let's get x by itself. Let's take away 3. We have 2x is less than or equal to 4. To get x by itself, I'm going to divide by 2. And that gives me x is less than or equal to 2. This is special inequality. This has a special graph, right? Since it's not in slope-intercept form, we can't say that we have a slope necessarily, and we can't say that we have a y-intercept. Instead of a y-intercept, maybe you've guessed it, we've got an x variable here. We actually have an x-intercept, and that x-intercept is 2. The other thing, maybe you're wondering, well, what would the slope of this line be? If I'm going to intersect the x-axis, this is that other special slope that is undefined slope. And if you can picture slope dude with his undefined slope, that's that vertical line, that straight up and down line. All right, so go to your coordinate plane. We need to, instead of going up or down to graph the y-intercept, we have to mark our x-intercept. So we're going to go to the right 2. Mark that point for me, please. And then we're going to draw a vertical line. Before we draw that vertical line, we need to check our inequality. Since it's less than or equal to, it is going to be a solid line. So that will be part of our solution. So I need a solid line going straight up and down. Then last thing we got to do is just use that test point. We can use the origin here because it's not on that boundary line. Since we just have x, we're going to plug 0 in for x. Super easy check. Is 0 less than or equal to 2? And the answer is yes, right? That is a true statement. 0 is less than or equal to 2, meaning the origin is part of our solution. So when we go to shade, I'm going to pull all these solutions, everything to the left. Or I could move my entire coordinate plane. That's fun too. Let's try that again. Let's see if I can get there we go. Keeping me on my toes. All right, so all of this gets shaded, everything to the left. Awesome, meaning our boundary line is part of our solution. Everything to the left of that boundary line is part of the solution, origin included. That is all part of something that you could say fits a true statement for that inequality. All right, last one, save the best one. Here we go. I'm going to get back to my pen mode here. All right, last one to copy down. Find that last graph blank, please. It says 5y minus 3 is greater than 17. 5y minus 3 is greater than 17. Goal being, once again, to get this into slope-intercept form. Since we do have y, we can solve and get y by itself. So first thing I could have to get rid of that minus 3 with a plus 3. I've got 5y is greater than 20. I need to divide by 5, so I have all y's greater than 4. You guys have seen this before, right? This is another special equation, but this one is in slope-intercept form. Give me a blank for m and a blank for b. In this case, you've got a y-intercept of 4. You don't see the slope with this one because the slope is 0. Awesome. All right, so we can go over to our coordinate plane. We can go to the origin, go up 4, mark that point. Before you draw your line, remember that slope of 0, that's that horizontal line. Check your inequality. Since it's a greater than, we have to use that dashed line. So we're going to do a dashed line going horizontally through 4 on that y-axis. Last thing we got to do is just test to see, do I need to shade everything above this horizontal line or everything below in order to get the rest of my solution? So in your test work, all we got to do is plug in y. We've got 0 is greater than 4. What? 0 is not greater than 4. Frowny. That means the origin right here is not a solution. That is a frowny face, meaning we need to color everything above. So the solution is above the boundary line, not including the boundary line. Everything above that dashed line is part of that solution. Excellent. All right, you should have 5 good examples complete on your yellow piece of paper. What I'd like someone in the front row to do, just like I always do, is grab the tape off my bookshelf, pass that down the left-hand side of the classroom, take a piece of tape, fold this yellow piece of paper in half, tape your notes into your notebook so you got them. So tape in your notes. Once the tape gets to the end of each row, could someone please pick up the tape, walk it back to the bookshelf? That would be great. Other than that, get going on your homework. Homework should be coming out now. Use your time. Get this done so you have nothing left for your evening tonight. Good luck, ladies and gentlemen.